Have you ever pondered upon the possibility of trading places with someone else, not just your place, but your mind, your thoughts, your brain? Bewitching as it may sound, the concept we're unfolding today is brain swapping. This idea of transferring one's consciousness, one's very essence, into another body has been a topic of fascination, often finding its place in the realms of science fiction and popular media. From the eccentric experiments in Mary Shelley's Frankenstein, to the mind-bending adventures in films like The Matrix, Avatar, or even the recent Altered Carbon series, the theme of brain swapping or consciousness transfer has tickled our curiosity for centuries. It's not just fiction that has us enraptured. The intriguing possibility of brain swapping sparks questions in our minds. Could we, one day, wake up in a different body with a different life, yet still retain our original thoughts, memories, and personality? Imagine the possibilities. Could we not only switch bodies, but also experiences, perspectives, and even skills? A mathematician's brilliance be shared with a struggling student? The concept of brain swapping also gives rise to a fascinating discourse about identity and self. If our consciousness is transferred to a new body, would we still be us? Or would we become a blend of the original and the new host? Would our identity be tied to our original brain or the new body? As we delve deeper into this subject, we'll explore the current scientific understanding of the brain, consciousness, and identity. We'll look at what researchers have to say about the feasibility of brain swapping, and we'll also touch upon the ethical and moral dilemmas associated with it. The idea of brain swapping, as fantastical as it may seem, opens up a Pandora's box of questions, theories, and debates. It's a subject that goes beyond science, touching upon philosophy, ethics, and the very notion of what it means to be human. As intriguing as it sounds, the question remains, can brain swapping ever become a reality? To understand the feasibility of brain swapping, we first need to delve into the complexities of the human brain. The human brain is a marvel of biological engineering. It's a supercomputer of sorts, storing memories, processing thoughts, and controlling every function in our body. It's made up of approximately 100 billion neurons, each capable of making about 10,000 connections with other neurons. This intricate network is the powerhouse of our consciousness, our personality, our very selves. These neurons communicate using electrical signals, sending messages at lightning speeds. They control everything, from the rhythm of our heartbeats to the blink of our eyes, from the surge of our emotions to the depth of our thoughts. But the brain isn't a standalone organ. It's intricately connected to the rest of the body through the spinal cord and the peripheral nervous system. It's these connections that allow the brain to control the body and receive sensory information from it. Now, imagine trying to disconnect this intricate network, preserving the brain, transporting it, and then reconnecting it in a new body. The scientific challenges of such a procedure are immense. Firstly, we'd need to somehow sever the connections between the brain and the rest of the body without causing irreversible damage. Then, we'd need to keep the brain alive and functioning during transportation, which is a daunting task, given the brain's need for a constant supply of oxygen and nutrients. Lastly, and perhaps most challenging of all, we'd need to reconnect the brain to a new body. Each of the billions of neurons in the brain would need to be precisely reconnected to allow for the restoration of normal brain function. This is a task that is currently far beyond our technological and scientific capabilities. Given these complexities, it is clear that brain swapping is not a simple task, but is it an impossible one? With our current understanding and technology, the answer is yes, but who knows what the future holds? After all, the realm of science is always expanding, always pushing the boundaries of what we believe is possible. Scientists and researchers are exploring the frontier of neurology and consciousness, bringing us closer to the reality of brain swapping. But how close are we exactly? Let's delve into some of the recent advancements and theories in this field. In the domain of brain-computer interfaces, or BCIs, researchers are making strides in connecting the human brain directly to machines. Imagine a world where you could control a device or even a robot with your thoughts alone. While this may sound like science fiction, it's becoming less so every day. In fact, just a few years ago, a team at the University of Pittsburgh enabled a paralyzed man to feel sensation again by connecting a robotic arm directly to his brain. This is a significant step towards understanding how we could potentially transfer our consciousness to another body. Next, let's consider neuroprosthetics. These are artificial devices that replace or enhance the function of a part of the nervous system. What's fascinating is that with neuroprosthetics, we're not only looking at replacing physical parts of the brain, but we're also considering the potential to replicate cognitive functions. This means that we're getting closer to understanding the mechanisms behind our thoughts, memories, and consciousness. Speaking of consciousness, this is where the discussion gets really interesting. The science of consciousness is an emerging field that seeks to understand the nature of our subjective experience. Some theories, such as the ORC theory proposed by Roger Penrose and Stuart Hameroff, argue that consciousness is a quantum mechanical phenomenon. If this holds true, it could imply that our consciousness is not confined to our biological brains and could, in theory, be transferred. While we are still far from achieving brain swapping, these advancements in neuroscience are paving the way to what might be possible in the future. So, while we may not be ready to swap brains just yet, we are undoubtedly taking steps in the right direction, exploring the fringes of our understanding and pushing the boundaries of what we once thought was purely science fiction. Stay tuned as we continue this fascinating journey into the unknown realms of our minds. But even if brain swapping becomes a reality, should we pursue it? The ethical and moral implications are immense. Let's delve into this. First, consider the issue of identity. If you swap brains, do you become the other person or remain yourself? This raises profound questions about what makes us, us. Is it our physical bodies, our memories, or something else altogether? Then there's the matter of consent. It's not enough for one party to agree to the swap. Both individuals would need to fully understand and accept the potential ramifications. This is a high bar to clear. After all, how many of us truly comprehend the intricacies of our own minds, let alone the prospect of inhabiting someone else's? And what about the potential for misuse? With any significant scientific advancement comes the risk of exploitation. Imagine a world where the rich could buy the brains of the young and healthy, or where criminals could forcibly swap brains to evade justice. These scenarios may sound like science fiction, but they're the kind of ethical dilemmas we would need to confront. Of course, there may also be benefits. Such a procedure could theoretically offer a new lease of life to those with debilitating physical conditions. It could even pave the way for a form of immortality if our brains could be continually moved to new bodies. But would these benefits outweigh the ethical concerns? That's a question we need to grapple with as a society. It's not enough to ask whether we can do something. We also need to ask whether we should. In the end, the ethics of brain swapping are as complex and multifaceted as the brain itself. As we push the boundaries of neuroscience, we must also navigate uncharted ethical waters. As we continue to explore the limits of our understanding of the brain, we must also consider the potential consequences of our discoveries. Today, we have ventured into the realm of brain swapping, a concept that fascinates and challenges our understanding of the brain. We delved into the intricate scientific complexities that make this concept a daunting task. From the billions of neurons and synapses to the delicate task of connecting them, it's clear that the science behind brain swapping is far from simple. We also explored the cutting-edge research in this field, with theories suggesting the potential of brain swapping to treat neurodegenerative diseases or even achieve a form of immortality. However, this is still largely theoretical,